Okay, let's carry on talking about electronegativity. Electronegativity is the ability of an atom to attract electrons towards itself in a covalent bond. We said okay, so if we think about the trends in the periodic table over here in this green box, right? As you go up the as you go up a group, the atoms become more electronegative because the nucleus is closer to the bonding electrons because the atoms are smaller, and so they are more electronegative. And then as you go across a group, the electronegativity increases there because you've got more positive charge in the nucleus. So here's my little sketch of the periodic table here. So we've got hydrogen in there and helium there. Okay, now let's think about this top row here. We've got boron, carbon, oxygen, nitrogen, beg pardon, nitrogen, oxygen, fluorine, and neon. Okay, and then this is group 7. We've got chlorine, bromine, iodine. I'm not really concerned with too much to the left of the staircase line because they are all metals, and well, metals do form some covalent bonds, as we'll see later on, but I'm just thinking about the non-metals really. I'll just put in aluminium there to remind us here. Aluminium is very close to the dividing line, and that does form some covalent compounds. So of the other elements there, what we're interested in, well, silicon, yeah, put it in, but we not really that interested in it. Phosphorus, yeah, sulfur, and these are the ones here. We don't really talk about them very much. We can forget about these noble gases because they don't form covalent bonds, generally speaking, so we can't really meaningfully talk about their electronegativity. So you can see which element is furthest up to the top and furthest to the right. Well, it is fluorine, and fluorine is the most electronegative element in the periodic table. Everyone would agree with that. So here's our E negativity league table. We've got fluorine at the top. And then the next most electronegative element is oxygen. And then it's nitrogen. And then there's a little bit of a break. Most people would say they are the sort of super group of electronegative elements. And then a little bit below that, you'd have chlorine. Importantly, let's look where carbon and hydrogen are usually considered to be approximately about the same electronegativity as each other. That's very important because if you think of all the compounds with carbon and hydrogen bonds in, and then those bonds, the electrons are shared evenly in there. There's none of that delta positive, delta negative thing we talked about in the last video. Now, you may think, oh, well, this rule about, higher up and further to the right is more electronegative. So you might think, well, which is the most electronegative out of sulfur and bromine? Well, that's a matter for debate, and I don't really know, to tell you the truth, and you don't really need to worry about it. You say, yeah, sulfur is more electronegative because it's higher up, but bromine may be more because it's further to the right. We won't worry too much about that. But what we really do need to know about is this table here, which I've drawn. Okay, so we need to understand that is the order of electronegativity. Right. So what we've done now is I want to say I'm going to give a series of compounds, and you've got to say, are we getting even sharing in those compounds, or are we getting, are the electrons not shared evenly? Okay, so I'll just write down the order again. Okay, so we've got F, O, N, bit of a gap, chlorine, and then carbon and hydrogen about the same. Right, I'm going to go to number, what you can do is you can pause this video in a minute and then you can fill this in yourself. But I would just say, let's look at number 14 here. All right, that's ethane. And there is no delta positive or delta negative. There's no partial positive or negative charges on the carbons or hydrogens because they've got the same electronegativity. a negativity, and that's very important. Most hydrocarbons, they don't have any partial positive or negative charges, and that is going to have an effect on the intermolecular forces they form, which we talked about briefly. So pause the video now. I'll do the first one, and then you can pause it. So carbon here, I say oxygen is the most electronegative, so that's going to be delta minus. So that means that hydrogen is going to be delta positive, and that carbon is probably going to be delta positive, partial positive charge in that carbon. Just remind what these little things are, right? That means it's got a slightly more of the electron than it should have. You wouldn't write just like Cl minus, because that means if you just write minus, it's got a whole electron's worth. This is not a whole electron's worth, it's a part of an electron. Okay, so that's how you've got to do these. So pause it, fill in any delta positives, delta negatives, and then come back to find out the answers. Okay, so I'm presuming you've paused it. Let's now have a look at what's going on there. Right. Number 2, nitrogen are very electronegative. This is ammonia, yeah, so you're going to have that is going to have that's going to be delta minus. It's going to be very uneven sharing of the electrons in this molecule. You're going to have a negative end to the molecule, the nitrogen, and the hydrogens, where the hydrogens are more positive. Let's do number 8. Right, fluorine, you think very electronegative element, yeah, but okay, there will be no delta positive because they're both as electronegative as each other, so you're going to get even sharing of the electrons there. Likewise, with bromine, it's fairly electronegative, but it's bonded to another bromine, so no delta positives, delta minuses there. Let's look at water. Right, this is definitely a very polar molecule, we'd call it. Polar means you have uneven sharing of the electrons. You have a negative end to the molecule and the positive end. The oxygen is definitely going to be negatively, more negatively charged than the hydrogen end. HCl here, right? Chlorine fairly electric, so that's delta minus there and delta positive. That would be like that. This one, minus there. Now this is an interesting one. A covalent molecule made of 2 halogens, and the chlorine is more electronegative, so that's going to be delta minus, and that's going to be delta plus. You might think if you had another one here, let's put another one in. If I had fluorine and chlorine, now in that case, that would be the other way around, wouldn't it? Because the chlorine would be delta positive there, because that is less electronegative than the fluorine. Oxygen, usually delta minus, but in this molecule it's not, it's delta plus, because it's bonded to the very electronegative fluorine atom. This one here, chlorine, that's going to be a delta minus on there and a delta plus on the carbon. This one, ethylamine, is an amine. It's quite very similar to this ammonia molecule. Okay, these are, you've got very similar things going on here. So the nitrogen, delta minus, the hydrogen, slightly positive. And this carbon and hydrogen bit of the molecule, that's all going to be even sharing of electrons in that part, because they've got the same electronegativity. Ethanol, this molecule, okay, should be fairly familiar to us. And I just want to draw your attention to how similar it is to water, because you've got that OH group. So you do have a delta negative there and a delta positive there on the hydrogen. So ethanol is a pretty polar molecule, just like water is. Ethene, we've said no, it's not polar, is it? Yeah, even sharing electrons. Finally, ethanoic acid, vinegar, okay? GCSE, you've come across this. This is definitely polar. That's going to be delta positive there, delta negative there, delta negative there. And the delta positive on the carbon is going to be particularly strong there, isn't it? Because it's connected to 2 oxygens, and both of them are going to be withdrawing electrons from there, okay? Good, so hopefully you got all of those right. Now, a little bit of jargon, which we say all of these molecules with have delta minus end and a delta positive end, we say they are polar. You say people are poles apart, aren't they? So it means the charges are apart, the center of positive and negative charge, they're polar, or you can say that they have got a dipole. They possess a dipole, and sometimes you could say that is a permanent dipole. This idea of molecules having uneven distribution of the positive and negative charge is really important for the formation of intermolecular forces, which we will talk about in the next video.